Welcome back to my channel. We are continuing our sequence of integration, and today we are dealing with the following integral. We'll use integration by parts to solve it. Why? Some of you may ask. Because cosine of x and sine as well does not change its structure under differentiation nor integration. It preserves its structure. I mean cosine of x, pi x, derivative with respect to x is what's that, minus pi sine x px. Differentiation, let's say it like double differentiation, it's again what's that, minus pi square cosine of p pi x. So as you may see, after even number of differentiation we'll have cosine, after odd one we'll have sine, but the main issue, the main problem why we use integration by parts is because we have polynomial here, and under differentiation polynomials, they decrease their degree. So after some point, after degree times of polynomial differentiating it, we will get eventually constant, so that we can focus on only initial function of ours, which is cosine of pi x. First, why there was such a talking? It's because we'll take x square as the function which we will differentiate. So it's, say, f, it will be g prime. In our next step, what we'll have, remember integration by parts, as before I don't use this du v method, I'll just make it in my head. We have f, it's x square, and let's integrate cosine of pi x in our head. What's that? It will be sine of pi x divided by pi, right? Because its differentiation will give us cosine of pi x. Alright, minus, we already have sine pi x over pi in our hands. What we add is the derivative of x square, f prime, which is 2x dx. Our next step, let's move towards the left a little. We write x square sine of pi x over pi minus 2 over pi integral of what we have in the end, x sine of pi x dx. What's that? Again, as you may see, we preserve our structure, but polynomial decreases its degree. So we need to apply integration by parts one more time. And we have sine pi x over pi minus 2 over pi, and this time again we will use polynomial as f and the trigonometric function as g prime. What we get is we write x, then we integrate g prime, which will give us what? Integral of sine of pi x is minus cosine of pi x divided by pi, right? Why is it so? Because if we differentiate it with respect to x, we'll get sine of pi x. Right, minus integral, we just repeat what we wrote, cosine of pi x over pi, multiplied by derivative of polynomial, derivative of f, which is 1 actually. So as you can see, we really decreased the degree of our initial polynomial, and we preserved the structure of our function, trigonometric function, so that we can integrate it now easily. Alright, let's just write x square sine of pi x over pi. Then what we have here, we have minus plus 2x cosine of pi x over pi square. Then here what we have is plus integral of cosine of pi x, which is indeed sine of pi x over pi, right? So we keep that in our minds. Here we should add minus 2 over pi square. It's this and this. This gives us plus. So and then integral of cosine pi x remains, which is, as we said, sine of pi x divided by pi, and plus some constant c. And that's actually our final answer. Let's repeat it in a pretty way. X squared sine of pi x divided by pi plus 2x cosine of pi x divided by pi square minus 2 over, let's write it in this way, 2 sine of pi x divided by pi cube plus some constant. And this is our final answer. That's it. So the solution of our problem is the following. I hope this video was helpful. Feel free to leave any comment or any questions. If you didn't understand some parts, I'll try to answer them, each of them. And see you on next videos.